Alright, we are looking at day 3. Our 2D and 3D shapes. We're doing volume today. So, prisms and cylinders are the same formula because, remember, a cylinder is just a prism with a circle base. So, the capital B stands for base area. Whereas most of our area formulas include a little b, and the little b stands for like the base of that object, not the whole base area. So capital B's are different than little b's, okay? H stands for the height. So what makes it 3D? It's the distance between the bases. And we'll do some examples of these, but the height is the distance between the bases, the height of the cylinder, the height of the prism. Pyramids and cones both go to a point, okay? So since they both go to a point, it's 1/3 the base area times the height. Again, capital B stands for base area. So if it's a cone, the base area is a circle formula. You could have a square pyramid, and the base would be a square formula. Spheres, I want to point out, this is the only one that we have that has r cubed on it. It's 4/3 pi r cubed. Just watch that. We have so many examples where we do pi r squared. A lot of people will just automatically do that, but with a sphere, the volume is 4/3 pi r cubed. Alright, so one thing you might want to figure out is, what do you think the base of the picture is? The base isn't always what it's sitting on. On this particular one, I could go with the base is this. So volume equals the base area times the height. Well, in this case, our base is length times width and then times height. This is the one most people volume, that's the formula you think of. So 17 times 9 times 24. Multiply those together and we get 3,672. This will be centimeters cubed because we are doing volume. Like I said, a rectangular prism is what most people think of when you say find volume. Okay, this one though is not a rectangular prism. It's sitting on a rectangular, but I wouldn't call it a rectangular prism. I would call this one a triangular prism. So, the volume would be capital B, and so the triangle formula is 1/2 little b little h for that represents the triangle. And then you have times the height of how far the base is apart. So for our picture here, we would have volume equals the triangle would be 1/2. The base of the triangle is 11. The height of the triangle is 5.4. Okay, so this whole part represents the triangle. And then you say, okay, if that's the base, how far apart are these bases? So if I colored this in, and I colored that back triangle in, this number here is how far apart are the bases. So we're going to take that number times 60. Okay? And round to 475.2 millimeters cubed. This one had a typo on it. You'll see the one I circled said inches for some reason. Everything else, that was just strictly a typo. This should say millimeters. So don't get confused. We weren't trying to trick you on converting things or anything. Literally is a typo. So that was the height. That's how far apart the bases were. Okay? Alright, this one's called a trapezoidal. prism. Again, prisms, we do volume equals the base area times the height. For a trapezoid, the area of a trapezoid is 1/2 height times B1 plus B2. So I'm going to put that whole thing like in a bracket or parentheses to show that part's the trapezoid. And then you have this H out here that represents how far apart are the trapezoids. Okay, so let's try this. Looking at our trapezoid, they gave us all the information we need. This is 36 because it matches here. So we have the trapezoid part is 1/2. The height of the trapezoid is 17.9. And then the bases are 14 plus 36, or 36 plus 14, however you want to write that. So you're going to take that area, okay, the trapezoid, let's just do that part, 0.5 times 17.9 times 14 plus 36. So the trapezoid part is 447.5, and then we're going to take that times the height. The height is how far apart are the bases. So, how far apart are the trapezoids would be 25. The distance between those two trapezoids is 25. We get 11,187.5. That would be meters cubed. Okay, so we're using the same formula on all these pictures because all these are prisms or cylinders. On a cylinder, we have volume is base area times height. Well, the base of a cylinder is a circle, and your circle formula is pi r squared, and then times the height of the cylinder. So let's see. Pi times 18 squared represents the circle, and then you're going to times that by the height, which would be 15. And on the homework, and I think on the test on this one, it says leave in terms of pi. Okay, so to leave in terms of pi, we're going to do 18 squared times 15. We're going to get 4,860. And then you just keep that symbol pi. And this would be inches cubed. So you just multiply the numbers, and then you leave the pi with that answer. That's in terms of pi. Alright, so that was everything related to prisms and cylinders. The next one we're going to cover is pyramids and cones. So a pyramid and cone problem, you basically do the same thing, only you're going to divide your answer by 3. A third of something is the same as dividing by 3. Or if you have a fraction button, you can put in 1/3, that works too. Alright, so this first one we're going to say is a rectangular pyramid. So everything in this section is 1/3 the base area times the height. Remember, capital B is base area. So if the base is a rectangle, your rectangle formula is 1/3 length times width, and then we're going to have times height. Okay, so 1/3 21 times 9, and then the height, you notice the height is always where the 90-degree corner is, so times 5. Multiply those, divide by 3, you should get 315 yards cubed. is a cone. Okay, so 1/3. The base of a cone is a circle. So we need the circle formula for this one, which is pi r squared, and then times the height of the cone. Pi times 9 squared times 17. Again, this one, because it has a pi, they're going to say leave in terms of pi. So you can see that? Okay. Alright, so I'm going to do 9 squared times 17, and then I'm going to divide that answer by 3. So I get the volume is 459 pi. And this would be yards squared. The only thing I would say to watch out on any of these like pyramid or cone questions is sometimes, if you remember, they give you what's called the slant height instead of the regular height. The height's located at the 90-degree mark in there. So just a quick recap, if you were to have like a I have a cone here, and instead of they give you the radius, and then they give you this number. So if they give you, remember the height's the 90-degree point, if they give you the slant height instead, let's say they say the radius is 5 and this is 12, this is called the slant height. And this in here is called the height. So if they ever give you the slant height instead of the height, just remember you have to do Pythagorean theorem to find that height, so that you know what this in, where it says base area times height, you might have to use Pythagorean theorem to find the height if they give you what's called the slant height instead. These examples we gave you the height on all of them, but one should be surprised. We talked about that with surface area, but it could happen on these volume ones too. Alright, this one's a little more tricky. On the bottom we have what's called an equilateral triangle. So we'll call this a triangular prism. No, sorry, triangular pyramid. Goes to a point, Miss Campbell. Okay, so, but you'll notice this triangle on the bottom. They show you that it's 10, 10, and 10. But they don't give you the height. And the triangle formula says we need 1/2 base times height for the triangle, and then you need like the height of the pyramid. Well, I need to figure out what would be like a height inside there. So if this comes down, it actually meets in the middle. So that would be 5. We're going to do Pythagorean theorem. So like x squared plus 5 squared equals 10 squared to figure out that height in there, just to do the base formula, okay? I got square root 75. About 8.66, so I could round to 8.7. And that's the height inside this little base triangle here. So when I go over here to do my formula, I would say the volume equals 1/2 times 10 times 8.7. So those numbers represent the triangle part, the base. And then we also would have the height of the pyramid, which is 16. And then the other thing that I forgot to write at the beginning, so maybe I'll write it at the end, was the 1/3. 1/3. Okay? We have to do the 1/3 because it's a pyramid, which means it goes to a point. So let's rewrite it. off the 1/3. So 1/3, the triangle part, and the height of the pyramid. And I got the volume is 232 centimeters cubed. Alright, so all those had 1/3 in front of them because they all go to a point. Pyramids and cones have the same formula. The last one is a sphere. A sphere has its own formula. Volume of a sphere is 4/3 pi r cubed. This one has a radius of 7. This one says leave in terms of pi. So today, anything that has a pi symbol in it, we're going to leave it in terms of pi. Okay? So to do that, I'll take 4 times 7 to the 3rd power. That would equal 1372 divided by 3. Keeping the letter pi. So I just did 4 times 7 cubed to get that big number. Now it's to divide and see if they come out even. They don't. I can see if it reduces at all. I don't think it does. Nope. 3 doesn't go in there evenly, and nothing else goes into 3. So this whole thing is your answer. Alright. And the thing about a volume, to find a hemisphere, you could just take that number and divide it by 2. So our 3 formulas today. Prisms and cylinders have the same volume formula. You take the base area, whatever the base is, times the height. Pyramids and cones, they go to a point, so you do the same base area times height and then divide it by 3. And the last one, spheres, is 4/3 pi r cubed.